Hello, people watching this video. We're just going to fill one last piece of information out on this yellow sheet that we need, and then I'm going to give them the rest of the time to work on the review. And tomorrow we're going to finish up that review and answer last-minute questions, and then we'll test probably on Monday over Chapter 6 and scoot right on into Chapter 7. So the last thing that we have is binomial. What do I want to call this? Binomial, let's say approximations. I don't know. We'll call it binomial approximations. Okay? And these are the ones that involve like the P's and the Q's. Okay? So do you guys remember we use this binomial approximation to do the bell curve thing when you get like an overflow error, right? Like we would try to do the NCR, P to the R, Q to the N minus R, like that formula that we learned like 2 chapters ago. But sometimes you get an overflow error, right? So we're using this process when we get an overflow error, and that allows us to actually find the answer. Okay, so in a binomial approximation, there are things that you need, and they are n for first, and n is the number in your sample or the total number. You need p, which is the probability as a decimal. We'll say probability success. It doesn't necessarily always mean success. It's just whatever you're talking about. Q then, they will usually never give to you. And Q is another probability, so it's probability of failure. And to find Q, let me write that better. F-A-I-L. And to find Q, it's 1 minus P, right? We know that, like 100% minus P will give you Q, or 1 minus P gives you Q. Okay, then we need X bar, which is the average or the mean, okay? And we need the standard deviation, okay? All right, and before we fill those formulas in, I'm going to go and give you an example first. So I kind of wrote that in important info rather than formulas. Oh, formula. We need z-score. Formula. Ha, there we go. So we do have something to write over here. Z equals. What is the formula?
What?
X minus X bar.
It's still X minus X bar. Yep.
The standard deviation.
Divided by the standard deviation. Still the same normal z-score. We just have to work. Like normally, like in the beginning of this chapter, we didn't have to work hard. We were given all of the X bar, standard deviation. Now we have to work for it. Like we have to find these two things before we can even do the z-score, okay? So that's the only difference here. Not really hard, okay? Let me try to think of an example. Let's do, my sample is gonna be 50 students. Okay, let's say 50 students, and the 50 students, and typically what happens is 70% of them pass the test, whatever test we're talking about. 50 students, 70% of them pass the test, okay? What are the chances, or find the probability, that, can we do 2 of them just to get the right idea? Okay. Find the probability that, I'm going to say 40 or more pass, and then let's find the probability, this is number 1. 40 or more pass. Number 2, we're going to do that exactly, I don't know exactly how many.
35.
Well, that's what 70% of 50 is. I was trying not to use 35. Let's say exactly 38 pass, just because I don't want to confuse them by using the same number. Does that make sense? Okay. Anyway. All right. There we go. Okay. Exactly 38 pass. All right. So here we go. We need to find, given this information, we have to find the mean. What's the formula even for finding mean? These are the things that we have to know. Okay. Let's write out what we have though for just a second. I'm going to use this little space over here. So hold on. N for my scenario over there is how many? 50, okay? And then the only other piece of information that's given to me is 0.7, and that is P. And that means Q is 0.3. Okay, so India said she knows the equation for finding the average, right? Okay, if I have 50 students and on average 70% of them pass, how many is that? We take N times P to find that average, right? That would just make sense. So 70% of 50 gives me an X bar of 70 times, no, wrong, 50 times 0.7. I said that backwards. And that is 35, I think, right? 35 students on average pass. That's going to be the number that I'm going to use, okay? Then we have to find standard deviation. So what's the standard deviation in comparison? Do you remember the formula for that? NPQ, write that guy down, okay? N in this case is 50, P is 0.7, Q is 0.3. And I promise I'm done writing in this box after this. Standard deviation is something. I don't know. The square root of really 35 times 0.3. Somebody get it? That's what I got. So standard deviation. So now it's just the same process as what we were doing before, kind of. We have to do the 0.5 thing. But it's the same process as before. X minus X bar divided by standard deviation, that stuff. Okay? All right, so to solve this, can I go over, or are you guys still writing? Hold up. Okay. Okay. All right, let's go over here and let's solve. So number one, we're still like taking this information and converting to a z-score. So that's what we're doing first. We got to do z-score. But let's draw a picture of it first. So number one, we have this going on here. And number two, we have this going on here. And we're going to write some stuff out. We're going to convert to a percent. We're going to call it a day. Okay, so, all right, what are some things that I can label on my first bell curve?
35.
I always start with 35. That's the average, that's the middle. 35 has to go there because I don't even know what I'm, like where I am at in comparison to that. Now we're comparing everything to 40, right? So 40 is this marking right here, and I'm doing 40 or more, right? Okay, so now, this is the only tricky part that's a little bit different than what we did before. In that, we can't just use 40 as my z-score number. We have to use the 0.5s, right? Okay, so then we have to decide which 0.5 are we going to use. Are we going to use 39.5 or 40.5? Okay, we're doing or more, which means we're going to the right, right? But I want it to include 40, right? So we've got to go on this side of the 40 in order for it to include 40. So I'm going to erase this other one, and we're going to go 39.5. Do you guys see why that works? Okay, if you map it out and draw the picture of the bell curve, it's so much easier to figure out which number you're using. So we're going to use 39.5, all right? Now let's convert to a z-score. So x minus x bar divided by the standard deviation. What minus what? Nope, other way around. 39.5 minus 35 over, what was our standard? 3.24, thank you. And I don't have to rewrite. 3.24. And the z-score is going to be some positive number like 1 point something. I don't know. Maybe not. Yeah, it is 1 point something. 1.39. Rounded to 2 decimal places. Okay. All right. Last thing. We got to look them up because if we didn't use the chart, then we didn't do it right, right? 1.39 is point what? 0.917. 0.9177. Okay. All right. If I look at this chart here, I can tell that 0.9177 is not the correct answer because we're looking at this range here, right? And that is not 91%, like looking at the proportion, right? 91% is going to be there back, so we've got to do 1 minus, okay? So don't forget to do that. 1 minus. Anytime you're going to the right, you'll have to do 1 minus. Anytime to the right, 1 minus, okay? Which is going to give me like 0.0823. So 8.23%. What does that mean? Just to like... We have an 8.23% chance that 40 or more students pass out of 50. That's not real good odds. But only 70% are passing in the first place. So, you know, that's why that number is so low. Okay, now this one over here, again, I always start with 35. But exactly when we're doing exact 38 pass, it's a little bit different, right? Okay, 38 is still going to be on the right side, not as far over as 40, but whatever, okay? And to do 38 exactly, we've got to do the 2 chunks. It's like taking a slice of like cake out of the center, right? Slice of cake out of the center. You know, like in the gender reveal cakes where they cut the 2 sides and they pull it out. That's what I think of when I think of this. Like you're cutting a piece of cake and then you're yanking that little chunk out and then you're done. All right, so we've got to do 37 and a half and we've got to do 38 and a half. Okay, 37 and a half, 38 and a half. We got to do 2 of them and then subtract them, right? Okay, so start with, let's do 38 and a half first because then that top number is going to be bigger, right? Yeah, it doesn't matter. 37.5 minus 35 divided by 3.24. Okay, so we've got those 2 z-score numbers. We're going to convert them to our percent.
Bottom is 0.77.
0.77. Okay. Top is something else other than 0.77. Like maybe 1 point something? 1.08? Perfect. Okay. What?
Oh, I see.
Because then we'll subtract, right? Okay. So now we're going to convert each of those to a percent. So 1.08 is like 80 some percent or something like that. 0.8599.
0.8599. And then the 0.77 is 0.7794.
0.7794. Okay. But I want that slice in between them, so I'm going to subtract. And I don't know, 5, 0, carry the 1, 0, 8. 0.80, 0.0805? I don't know. What does that mean? We have an 8% chance of what?
Exactly 38.
Having exactly 38 students pass out of 50. Which is, I mean, that's kind of ish likely, right? Okay, good? Yeah. Yeah. Nope. I mean, I'm not going to move yet, but anyway. Okay, good? Happy with that? So this is this chart. All right, you guys have a review. I'm going to float around. Is that the best way to do this, right? I will do any of them together with you that you want, but, you know, keep in mind you're going to have to do it on your test by yourself, so make sure you're absorbing what we go through. Anybody have ones that we want to go through together right now, you know for sure? Or you just want me to float? Okay, I'll float. All right, goodbye people in the video.